Okay, let's dive into this. Welcome to today's explainer. Take a quick look around you right now. I'd bet good money you're within arm's reach of a piece of paper. It's one of those things we use literally every day, yet we tend to take it completely for granted. But today, we're going to unpack the absolute magic behind it. We're looking at the massive industrial transformation that takes a rock-solid tree from a forest and completely restructures it into that delicate, flexible sheet of paper sitting on your desk. So, here is the central engineering mystery we're solving today. How in the world does a towering, unbending 100-foot tree turn into a 1 millimeter thin sheet that you can fold into a paper airplane? Honestly, it kind of sounds like alchemy, right? But to take that raw, stubborn force of nature and engineer it into a daily staple, you need an unbelievable multi-ton industrial process. We're talking about a wild balance of extreme mechanical brute force and incredibly precise chemistry. Here is our factory floor plan for this explainer. First, we go from forest to factory, then breaking down the wood. Next up, the legendary Fourdrinier paper machine. After that, pressing, drying, and finishing. And finally, the sustainable recycling loop. Let's get into it. Part 1, from forest to factory. Our journey kicks off exactly where you'd think, out in a lush forest where mature trees are sustainably harvested. From there, things move fast. We've got to mechanically break down these whole logs into uniform wood chips. So fleets of heavy-duty trucks haul the massive logs straight to the mill. And once they arrive, the brute force really starts. We use these absolutely massive, heavily powered rotating machines to just violently strip all the bark off the outside. Then, those debarked logs get shoved through heavy industrial blades, chopping them down into tiny, perfectly sized wood chips that are totally ready for the next phase. Which brings us to part 2, breaking down the wood. Now we're shifting gears from physical chopping to a microscopic battle inside these massive pressure cookers called digesters. We are hunting down a very specific target here, and it's called lignin. Think of lignin as this dark, rigid, glue-like stuff that naturally binds plant fibers together. It's exactly what gives wood its strength and stiffness. But for paper, stiffness is the enemy. So inside the digester, we mix the wood chips with a ton of water and specialized eco-friendly chemicals. We crank up the heat, apply extreme pressure, and this intense chemical soup essentially cooks the wood, aggressively stripping away that rigid lignin from the rest of the pulp. Now, what's really interesting about this slide is the stark contrast between that dark, stiff lignin we just got rid of and what's left behind, cellulose. Fun fact for you, cellulose is actually the most abundant organic polymer on Earth. It's made up of these bright white, super flexible fibers from the plant's cell walls. Once we ditch the lignin, the raw pulp gets thoroughly washed, meticulously cleaned, screened for any leftover impurities, and finally bleached. This extreme purification isolates the precious white cellulose fibers. This is the absolute gold we've been mining for. It is the core ingredient of your paper. Moving on to part 3, the Fourdrinier paper machine. To actually make the paper, that pristine white pulp gets mixed with a massive amount of clean water to create what we call a thin fiber slurry, essentially a watery soup. Then enters the legendary Fourdrinier paper machine. This thing is an absolute marvel of continuous engineering. It takes the slurry and spreads it evenly across a wire mesh conveyor belt that is racing forward at literally highway speeds. As it flies down the line, gravity and vacuums aggressively suck the water straight down through the mesh. And as that water escapes, magic happens. Those loose cellulose fibers physically interlock and bind to each other, instantly transforming from a puddle of soup into a single, continuous wet sheet of paper. Part 4, pressing, drying, and finishing. So the crucial point is that we now have an unbroken sheet, but it's completely soaked. Right, it's soaking wet and incredibly fragile. To get it crisp and usable, we hit the pressing stage. The wet sheet goes through these giant rollers that literally squeeze it, forcing out a huge amount of excess water. Next is drying. The sheet weaves its way through a series of heated steam cylinders, basically baking it until it's almost entirely dry. Finally, we hit the calendar stage. These are heavy polishing rollers that apply intense pressure to smooth out the surface. This is what dials in the final thickness and gives the paper that perfect, pristine gloss. But before this beautiful paper can leave the mill, it has to pass a pretty intense test. High-tech quality control cameras are mounted right above the fast-moving line, constantly scanning every single square inch for even microscopic defects. Only after it aces that high-speed inspection is it wound up into these absolutely massive industrial rolls. We are talking rolls that weigh several tons. From there, they systematically chop those giant rolls down into the standard everyday sheets we use, package them up, and neatly label them. Which leads to part 5, the sustainable recycling loop. We've spent most of this explainer zoomed way in on microscopic fibers and heavy machinery, but let's zoom back out to the global scale. Those packaged sheets are loaded up and shipped out everywhere. The stuff that started as a rigid tree in the forest is now supplying schools with notebooks, offices with printer paper, bookstores with fresh novels, and homes worldwide with everyday essentials. The sheer scale of this global distribution network is honestly just staggering. Let's move to and see how this builds into a really remarkable ongoing life cycle. On day 1, a tree is sustainably harvested. By day 2, it's pulverized in the digesters and rocketing through the Fourdrinier machines. By week 1, the finished sheets are on transport ships crossing the globe. But here is the kicker. The journey doesn't end there. By year 1, that same paper is used, collected, and tossed back into the system to be recycled into brand new paper. That loop is absolutely vital. Recycling is what protects our remaining forests and seriously slashes global waste. We've tracked an astonishing feat of engineering today, from a quiet forest through a roaring factory, right into your hands. But a circular economy only works if we actually close the loop. So I'll leave you with this final thought. As you look at the paper in your own life, what is your personal role in making sure this incredible journey is a continuous, sustainable loop and not just a dead end? The next time you grab a blank sheet, remember the engineering marvel it took to create it, and make sure its story doesn't end in a trash can. Thanks so much for joining me on this explainer, and I'll catch you on the next one.